Let's say we want to add two numbers together and assign them to a variable. So we can do this like this. We'll create a variable right here on the command line. We'll call it num, and we'll follow that with $, opening parenthesis, and then an expression here, 1 plus 2, and we'll close that with these double parentheses here. So this $, parenthesis syntax is called arithmetic expansion. Bash evaluates the arithmetic expression within the double parentheses, and it returns or substitutes the answer in its place. So now num, the variable num, should contain the value of 3, and we can check it like so. And sure enough, it does. Okay, let's do some subtraction. We'll set num equal to 10 minus 1, and the value of that is 9. Multiplication is handled with an asterisk, so let's do that. 2 times 4 is 8. Division is handled with a /, so we can do this. Let's talk about this particular situation. So we'll do 6 divided by 4. And then bash returns 1. So 6 divided by 4 is actually 1.5. But again, bash just returned 1 to us. So here's what you need to know. Bash doesn't do any rounding. It just drops off the decimal point and anything after it. So really, bash doesn't support floating point arithmetic. That's usually fine because what you'll end up doing most of the time is very simple math, like adding two numbers together or incrementing a number by 1 during a loop and things like that. If you need to work with numbers that contain a decimal, then you're going to need to use an external program such as BC, which stands for Basic Calculator. Now, it might not be installed by default, so if you do this, type -a BC, and you don't see it there, then what you would need to do is sudo yum install -yes or -y, BC to install it. So here I have it installed, but you may not. Again, you may need to install it. So let's get some help on this thing here, -h. If you want to do floating point math with BC, you have to turn on the math libraries with the -l option. Also, it's important to know that BC reads from standard input, so you can do things like this. We can do echo 6 divided by 4, and we'll pipe that into BC, and we'll use the -l option, and it returns 1.5. By the way, if you need a quick calculator at the command line, you can just run BC-L and then do that here as well, 6/4 or 1 + 1 or whatever you want to do. And then you can type Control-D to exit out of the calculator here. Quickly, you can also use awk to do this. It's a little bit more cumbersome, but I'm just going to show you quickly how to do it, and you can stock it away if you want to use it at some time. Again, I don't necessarily recommend doing this, but you may see this in other people's shell scripts. So we can use this awk begin, and then what we want to do is print 6 divided by 4, and that is 1.5. So whether you're using BC or awk, you get the full and complete answer. Now let's get back to bash. So 6 divided by 4 according to bash is 1. There is a remainder though when you do 6 divided by 4, and you can get that remainder with the % sign, also known as modulo or the modulo operator. So we can do this, num equals 6 modulo 4, and that is going to be 2. It prints 2 because 6 divided by 4 is 1 with 2 left over, or a remainder of 2. Now this comes in handy when you want to do alternating things. For example, you could treat all even numbers one way and all odd numbers in a different way. Even numbers divided by 2 always have a remainder of 0, while odd numbers divided by 2 have a remainder of 1. Then you could use a simple if or case statement to handle those different situations. By the way, you don't have to use hard-coded numbers like I've been doing here. You can also use variables inside the parentheses too. So we can do this, something like this. Dice A is equal to 3, dice B is equal to 6. And the total of those die would be dice A plus dice B. And of course, 6 plus 3 is 9. You might have noticed here that I didn't use a $ for dice A or dice B. Those are variables inside those double parentheses. You don't do that when you're using this particular syntax. By the way, you can assign or change the value stored in a variable. Here, you don't need the leading $. That leading $sign is used for substitution, but we don't want to substitute the command for its value. We just want to change a variable. Hopefully, just seeing it here will make more sense and it'll be clearer than me trying to talk through it. So let's do this. Let's set num equal to 1. And let's increment the value stored in the variable num by 1. And we do this by parenthesis, parenthesis, num plus plus, and then the closing parentheses here. And let's echo this. So now num is 2. So we've changed the variable without doing any output when we're using the double parentheses syntax, but it still affects the variable. Now let's decrement the value stored in the variable num by 1. And we can do this with dash dash or minus minus. And then 2 minus 1 is 1. And there we are. We have 1 stored in the variable num. Let's add a number to the value of the variable and store that new value in the variable. So we can do this, num plus equals 5. So 1 plus 5 is 6, and we assign that to num, and that is what is stored there. You can also do things like minus equal, asterisk equal, which is multiply, / equal, which is division, modulo equal, and so on. Now, if you wanted to, you could actually use substitution to change the value of the same variable, and it would look like this. We could do this. Num is equal to $, these parentheses, num plus equals 5. And that is 11 because 6 plus 5 is 11. What this does is takes the output of the num plus equals 5 operation and assigns it to the variable num. If that seems clearer to you, you can do it that way as well, or you can use the other syntax that I was just demonstrating. Now, before we wrap up our discussion on math, I want to show you 2 other ways to perform math operations that you might encounter in other scripts. The first way is with a let bash built-in. You can see all the operators that are supported by doing this. We'll just get some help on it, help let, and we'll pipe that to less. So you can see here the post increment operator of plus plus, the pre increment of plus plus that's before the variable name, plus and minus, the exponentiation, all these things that we're doing here, and these things that we were doing here like plus equals, minus equals, and so on. Now this let syntax pretty much does the same thing as using double parentheses. So let's do this. Let num equals 2 plus 3. And sure enough, that sets num to 5. You can also do this. Let num plus plus, and that increments it by 1. So now we have num with a value of 6. The second way you'll see math performed in scripts is with the expr command. The double parentheses syntax we've been using is built into Bash, and that's the route I recommend if at all possible. However, you can rely on external programs like we saw earlier with BC. So the expr command processes an expression given to it and then sends that result to standard out. So expr 1 plus 1, it returns 2. Now to do assignment, we just use command substitution like we would with any other command. So we'll do num. It's normal command substitution syntax. And again, 2 plus 3 returns 5. That is assigned to num, and that is what is displayed when we access the value stored in that variable. Okay, so that was a pretty long aside, but we needed to cover it before we could get back to getOps, and let's do that now. GetOps does not change positional parameters. What this means is that the options are stored in $@, $1, $2, and so on. So let's add a bit of code into our script to kind of prove this and point it out. So right here after our while loop and case statement, let's do this. Echo the number of arguments is stored in $pound. The contents of all the arguments is stored in $@. The first argument is stored in $1. Second argument is stored in positional parameter $2. Okay. So now let's exit our script and see what this does. So we'll do this luser demo 11-sl8, and we'll just type some extra stuff, if you will, at the end of the command line. So here we have 3 arguments. -sl is stored in $1, 8 is stored in $2, and extra -stuff is stored in $3. In my mind, once the arguments are processed, they should be removed as a positional parameter. Now, getopts doesn't do this for us, but it gives us a way to do it. So let's jump back into our code. Getopt sets a variable named opt_ind. It stores the position of the next command line argument following the options in that variable. So let's look at its value in action. So we'll run our same command here, and opt_ind is set to 3 because the third argument is the index or position where the arguments start after the options. If we want to remove the options that have been processed, that means we need to shift them down by 2. So stated mathematically, that's opt_ind -1. Now let's see if this little formula holds in some other examples. So let's do this. Let's just use -s and then some extra stuff. So sure enough, opt_ind is 2. So if we subtract 1 from 2, that leaves us with 1. And if we shift by 1, then what's left is anything supplied after the options. Now let's just run it with just some extra stuff without any options that we're checking for. Now in this case, like I said, there are no options and nothing needs to be shifted. However, our little formula still works because opt_ind is 1, 1 minus 1 is 0, and if we shift by 0, we change nothing, which is exactly what is needed for this case as well. So let's add this little bit of code or this formula or this algorithm, if you will, to our script. So we're going to shift by the number of opt_ind -1. Now we can process $@, $1, $2, and so on, just like we've always done. Now let's display the contents of $, etc. after the shift. So we'll do this echo after the shift. And we'll just grab all these up here and print them to our screen again. So now let's use luser demo 11.sh.sl8 extra-stuff. So sure enough, that works. The number of arguments we have at the beginning is 3. Again, -sl is stored in $1, $2 is 8, $3 evaluates to extra stuff. So after getopts is done and we process all those arguments, the only thing we're left with is extra-stuff, which after we do our shift is assigned to $1. And that's exactly what we want. So then we could do things like loop through all the other remaining arguments on the command line with a while loop, for example, while $@. We could then make people do things like after all your options, then we require you to give us a file or a username or whatever that we expect in $1. Then we can test and do some work against $1 and so on and so forth. However, let's say in this particular script, we want to treat anything other than the options on the command line as an error. And the easiest way to do that is to test the $pound value. So let's jump back into our script and say if If the number of arguments is greater than 0, then we're going to give them the usage statement and we'll get out of here. Again, we're going to reuse the usage function since it teaches the user how to use the script the way we want them to, and then it exits with a non-zero exit status. And remember, when you use shift, the number of arguments changes, and that also updates the $, variable, so this is going to work. Now, before we test our updated script, let's clean up our debugging and development code here, all these little echo statements, and make sure everything is all cleaned up. So let me go up here. We'll get rid of that. And we don't need these lines as well. Now let's do this. Let's run it with an argument. So here it gives us the usage just like we want. Of course, we exit with a non-zero exit status because it's using that usage function that we created at the top of our script. So let's do something like this. Let's say we'll pass a valid option and then also append some stuff to the end of the line here. And sure enough, it gets to that point where it's looking at the number of arguments after we've processed the command line options. And that has triggered the calling of the usage function as well. So let's go ahead and do this with something that is proper, a -s. And sure enough, we get our password with a special character appended to it. Let's do a quick recap. In this lesson, you learned how to use getopts to process command line options. You learned how to wrap the getopts command in a while loop and use a case statement to perform different actions for each option. When you want an option to take an argument, you follow that option letter with a colon in the ops string. You also learned how to strip away the options from the set of positional parameters by using the opt-ind variable provided by getopts. Finally, you learned how to perform mathematical operations. You learned that you could assign the result of an arithmetic evaluation to a variable by using the $double parentheses syntax. In addition to hard coding numbers in your expressions, you also performed arithmetic using variables. You even learned how to change the value stored in a variable directly using a few different operators, including the increment, decrement, and the plus equal operators.